Hello, all. Welcome to the world of forensic ballistics. Today, we will be learning about the firearms. Before that, we have to look into some of the definitions that are used in forensic ballistics. First one is definition of firearm injury. And firearm injury is defined as the injury that is caused by a firearm weapon. So basically, firearms or the bullets are usually round. It is classified as a puncture wound. The next definition is about firearm weapon. So, a firearm weapon is an instrument which propels out a projectile because of the pressure that is exerted by the gases which are formed. The gases are formed due to the combustion of gunpowder or the propellant. So, firearm is basically an instrument which propels a projectile. It can be a bullet or a pellet or otherwise a slug, and the projection of the projectile or the propulsion of the projectile is because of the gases that are formed inside the cartridge, and the gases are formed due to the combustion of gunpowder, which acts as the propellant to propel the projectile out of the fire. Next definition is about for firearm ballistics. And firearm ballistics is the branch of science which deals with the study of firearms and their investigations. So forensic ballistics are divided in basically into three parts. That is proximal ballistics, intermediate ballistics, or terminal ballistics. So, internal or proximal ballistics is a study of a projectile's behavior from the time of its propellant's ignition until it exits the barrel. So, basically, internal ballistics is a study of the projectile behavior that takes place inside the gun, that is before it exists the gun. And this includes a study of ignition method, because the ignition method, propellant, chamber, friction, inertia, etc. are different in different types of guns. So the internal ballistics study the ignition method in each gun, the propellant used in each gun, the chamber, the function of the chamber, the friction that is exerted on the barrel by the uh, bullet, then the inertia that it causes, then the pressure inside the gun, the bore diameter, and different other features that we will discuss later. Now, the second part, that is external ballistics. So, external ballistics is everything that happens after the bullet leaves the gun to just before the bullet impacts its target. So, after the bullet leaves the gun, the bullet will be subjected to various environmental factors like gravity, air resistance, humidity, wind, air density, and even latitude. And the effect of latitude is called Coriolis effect. So the Coriolis effect refers to the apparent force that is acting on projectiles over long range, but it is really due to the target moving with the rotation of the earth. So basically you can see here, this is the line of sight. So the uh, shooter's line of sight is like this. So if the shooter keeps the gun in a straight line and fires at the target, usually what happens is that the bullet strikes the lower part of the target. So to avoid that, or to hit the bull's eye target, the shooter will take a parabolic path, or the bullet will take a parabolic path. So for calculating the parabolic path, the shooter has to consider the gravity, the air resistance, the humidity, wind, air, crosswind, especially crosswind, then the air density, etc., to calculate the parabolic path. So Coriolis effect is basically due to the Earth's rotation. So object deflect to the right in the northern hemisphere, and the object deflect to the left in the southern hemisphere. This is called Coriolis effect, and this is purely due to the Earth's rotation. So if the sniper or the person that uses the rifle is in the north of the equator, is this side, in the northern hemisphere, the bullet, if aimed at the target, will be deflected to the right before hitting the target. So we have the striker has to, or the sniper has to consider this effect and to target this area. And in the south of the equator here, the bullet is deflected to the left. So the sniper will have to target this area to nullify the Coriolis effect. And if he fires bullet in the west, it flies lower to than those fired to the north or south, and the bullets fired to the east fly higher. So this effect has to be considered by the snipers to really hit the target. And this is basically refers to the very long range targets like 1 kilometer, 1.5 kilometer, etc. Some military rifles use long range rifles. So they have to consider the Coriolis effect before firing. And the third part, that is terminal or transitional ballistics, is the study of the behavior and the effect of the projectile when it hits and transfers its energy to the target. So this is the last part, that is terminal ballistics. So here the bullet design and the velocity of the impact largely determine the effectiveness of its impact. And in the picture you can see a .308 caliber bullet wound uh, in the body, that is the depth, penetration depth is shown here, and the wound diameter is shown here. Now we look into the parts of a firearm. There are four parts, that is barrel, then the action, the butt, and the magazine. We look into one by one. So barrel is a metallic tubular part of the weapon, and it may be short or long, and the distal end of the barrel is called the muzzle end, while the proximal end is called the breech end. So this is the breech end, and this is the muzzle end. You can see the mark in the muzzle end and the breech end here. And for sometimes the gun will be provided with foresight and hindsight. This is the foresight and this is the hindsight for vision. This is the foresight and this is the hindsight. The second part is called the most important part, that is the action, and this includes the breech clock, hammer, then striker pin, safety cock. This is the parts that are being mentioned. This is a hammer. There is a striking pin. It's a striking pin, or the firing pin is there. Then there is a safety cock. Then there is a trigger and the trigger guard. And there will be a chamber that tapers into the lead, which continues into the barrel. This is the area chamber, and the breech block is the mechanic plate which seals the breech end when the weapon is closed. So this is the breech, and there will be a breech block. This is the breech block that covers or seals or closes the aperture at the back part of the rifle or the gun barrel when this is not in use. So the breech will be blocked. Then the third part is the butt or the stock, and this is also known as the handle. And this can be wooden. This can be made of wooden or metal. And the fourth and final part is the magazine, and this is a spring-loaded block. And you can see the magazine, different types of magazine here. Here there is a magazine for a long-range rifle. This is the magazine or a chamber for a revolver, and this is the magazine that is used in a pistol, which is having the for comparison. A ballpoint pen is kept here to get an approximation of the size of the magazine. Then usually in case of a rifle, the magazine may be present in the front of the trigger guard. This is the trigger guard, and the magazine will be present in the front of the trigger guard, or sometimes a tubular magazine may be fitted at the breech end. In some weapons, a tubular magazine which contains a good number of bullets or a cartridge will be fitted at the breech end for continuous firing. And in case of a revolver, there will be a revolving drum. This is the revolving drum at the breech end, and this acts as the magazine. And uh, different capacity revolvers are there. Mostly it is six, but it ranges. The capacity of the magazine ranges from 5 to 9 bullets, and each chamber of the magazine acts as a chamber of barrel. And in case of pistol, the magazine capacities range from 6 to 14, and this is situated in or put in the butt of the gun. Now we are learning about the working of the firearm. Three mechanisms are there. First mechanism is the loading of the bullet. Second is the cocking of the bullet, and the third will be the firing. So for loading, majority of the weapons are loaded at the breech end. This is the breech end. Here it is the breech end. This is at the breech end. You can see the bullet loaded in a pistol. This is a revolver. You can see six chambers present in the uh, barrel. Then, sorry, drum. Then this is a muzzle loading gun. So usually most of the country guns are muzzle loaders. And you can see the uh, stick by which the different constituents of the cartridge will be separately packed through the muzzle end. This is a stick that is used to pack the constituents of the cartridge through the muzzle end. And sometimes loading may be done by pulling the hammer. This is a hammer, and it will be pulled, and the loading of the gun takes place. Or it may be by opening the breech end, like in shotgun cartridges you can open the breech end and load the shotgun cartridge here and uh, lock it. And the second action is cocking, that is done by pushing back the hammer or closing the breech end, so that the gun is ready to be fired. And the striker pin, it will be tensed. And we can look into how the revolvers work. That is, this is the first one, that is loading. Here the trigger is in the normal position, and here it is cocking, that is the trigger will be um, pulled back, and the hammer is in the striking position. And in the next uh, stage, that is firing, the hammer strikes the percussion cap, and this ignites the gunpowder, and the the bullet is released into the barrel. So the firing is effected by pulling the trigger, which releases the striker pin, so that it hits the base of the cat. This is the functioning of a revolver. Now we look into the function of a revolver. You can see in the first picture, the uh, gun is in the trigger is in the normal position. The cartridge is being loaded, and you can see in the second picture, the cartridge is in the loaded position. The trigger is pulled back, and the striker is ready, sorry, the hammer is ready to strike the bottom part of the, or the primer part of the cartridge. In the third picture, you can see the hammer striking the primer part of the cartridge, and the bullet goes off. And in case of a rifle, this is the firing pin, and in the first step, the cartridge is loaded into the chamber. You can see this is the a chamber, and the cartridge is being loaded into the chamber. In the second picture, you can see the cartridge is being loaded into the chamber, and the firing arm, sorry, for the firing pin is ready to be fired. Then the firing pin strikes the primer, and which gives an ignition, and this ignition is transferred to the gunpowder, which ignites and creates high pressure gases, and by the result of this high pressure gases, the projectile is pushed out of the barrel. And because this is a rifle, and the barrel is having a rifling effect, the bullet will be given a spinning motion. So basically, uh, the mechanism of action of a gun is like this. The striker pin will hit into the percussion cap. This is the percussion cap here, and the percussion cap is present in the middle of the base of the cartridge, and the hitting of the striking pin produces a depression on the cap, which leads to sparking, and the spark travels inside the flash holes. This is the flash hole. You can see the flash hole. The sparking travels through the flash hole and ignites the whole gunpowder, and this lead to the formation of gases, and the expansion of these gases exerts pressure on the bullet, and the bullet is propelled out of the projectile. The velocity with which the projectile leaves the muzzle end is known as the muzzle velocity. So, the velocity at which the muzzle or the projectile or the bullet leaves the muzzle end is known as the uh, muzzle velocity. So, depending on the muzzle velocity, uh, weapons can be classified as low velocity as well as high velocity. So, the velocity or the muzzle velocity is less than 1100 feet per second. It is called a low velocity firearm. And if the muzzle velocity is more than 1100 feet per second, it is called high velocity. So 1120 feet per second is the velocity of sound. And in this picture, you can see the cross section of a .223 cartridge. And here you can see the primer, the bullet, and the casing of the cartridge, and the final part, that is the bullet. Another picture showing the cartridge and its part and how it's work. This is the firing pin striking the primer, and there is a primer flash. And through this flash hole, the ignition is carried on into the gunpowder, and the burning gunpowder and the expanding gas exerts pressure on the bullet, and the bullet moves down the barrel. That's the basic mechanism of action of a gun. There are two types of firearm weapons: smooth bore weapon as well as rifle bore weapon. So based on the barrel, inside of the barrel, there are two types, that is smooth bore weapon as well as a rifled weapon. You can see the interior of the barrel. Here it is smooth bore, and here it is rifled, or it is given a spinning motion, or the spinning or the rifling. And you will see the rifling in the next slides. So examples for a smooth bore weapons are shotguns, muskets, air gun, air pistol, etc. And the second is the rifled bore weapon. So in a rifle bore weapon, the interior of the interior of the barrel is rifled. It can be a left twist or a right twist. And rifling means that along the length of the barrel, there are 2 to 20 uh, rifles are usually 4 to 7 and commonly six longitudinally, spirally twisted grooves so that the projectile or the bullet spins along its long axis before it leaves the muzzle end. An example for rifle bore weapons are revolver, pistol, stun guns, carbines, machine guns, sniper rifles, etc. And the depressions that are made on the barrel are called grooves, while the raised parts are called the lands. And the caliber of a rifled weapon is calculated by the distance between two lands or the raised part. And because of the spinning of the projectile, or what is the purpose of giving a spinning motion to the projectile? So, if we give a spinning motion to the projectile, the muzzle velocity will be more, and the firing range will be more, or the bullet can travel long distance, and there is better gyroscopic stability, that is less wobbling. And see wobbling here, the this bullet is called a yawning bullet, which shows a great amount of wobbling in the air. So, in order to reduce the or increase the gyroscopic stability, or to decrease the wobbling, we are giving a spinning motion to the projectile by rifling the barrel. And because of the spinning motion, another important achievement is that there will be better accuracy of the hit, and the bullet can penetrate through the body cavities. And this is the instrument, that is broach cutter, that is used to create rifling impressions in a barrel. Now we have to learn about the term caliber. Caliber is otherwise known as the bore of the barrel. So bore means internal diameter of the barrel. This is the barrel, and the internal diameter of the barrel is called the caliber. So a caliber means it is the signature of a gun. That is, guns are mainly classified along the diameter of the barrel. So in this picture, you can see the 12 gauge barrel or the 20 gauge barrel. How it is calculated, how the caliber of a gun is calculated. Mostly these are applicable to shotguns. So in shotguns, the bore or the gauge may be 4 to 32. The commonest bore is 12, and a range of 8 to 20 bore guns are being used nowadays. And the caliber indicates the number of balls made from 1 pound, that is about 453.6 gram of lead. So from 1 pound of lead, how many balls can be made that tightly fits in the barrel? That indicates the caliber of the gun. So from 1 pound of lead, 12 balls of about 0.727 inch can fit in a 12 gauge barrel. So each ball of 7 to 7 inch fits correctly into the barrel, and the total number of balls will be 12. So it is designated as a 12 gauge barrel. But in case of a 20 gauge barrel, for 1 pound of lead, we can make 20 balls, that is having a 0.617 inch diameter. So the diameter is slightly reduced in case of a 20 gauge barrel. This is how we will calculate the caliber of the shotgun. But in case of a rifled firearm, the bore or the caliber will be expressed in inches or sometimes expressed in millimeter. So in case of a rifle that we mentioned earlier, the caliber will be the distance between the raised part or the lands. We are not calculating the distance between the grooves, but we are calculating the distance between the lands. Here there is a 0.45, 0.458, 0.44, 0.444. .40, 10 millimeter, 9 millimeter, 8 millimeter, 7.62 millimeters, and different types of rifles are there. Now we are going to learn about the different types of firearm. The most common firearm that are used by people are shotguns, and this is about 3 feet long or about 1 meter long, and the barrel will be about 2 feet, 20 to 24 inches long. So two-third will be the barrel, and the barrel may be single or it can be double or multi-barrel, and they can be detached also. And when it is double, the barrels may be side by side or placed one above the other. These are called double barrel guns. And most of the country made guns and walking stick guns are usually 12 bore shotguns. Next type of firearm is the muskets that are used by railway protection force and sometimes by the police also. And the main feature of a musket is the presence of a bayonet that is placed in the muzzle end. The most dangerous type of firearm is the rifle bore weapon, that it can be an ordinary rifle, a repeating rifle, a semi-automatic or purely automatic rifles. And the rifle derive its name from the process of rifling. The most common rifles are revolvers and pistol, and they are about having 10 inches length, and they are mostly referred to as handguns. And the revolver derives its name from the revolving drum that is present in the breech end. And in case of a rifle, the pressure of gases in the chamber is about 20 tons per square inch. And in case of pistol or revolver, usually referred to as handguns, the pressure of gases in the chamber of a rifle is about 4 to 6 tons. And the bullet spins at the rate of 3,000 to 4,000 revolutions per second in a rifle. So you can see, you can feel about the revolution. Revolutions that are happening in the bullet, about 3,000 to 4,000 revolution per second. And these are some of the most commonly used assault rifles. You are familiar with the term AK-47, then M16 is there, MK-14 is there, MP5, MP7. Another AK is there, like AK-74. So these are the different types of assault rifles used by military and police. So for a academic purpose, we are looking into the weapons that are used by the Kerala State Police. So they use long-range weapons for jungle warfare. And for this purpose, self-loading rifles or SLRs, 7.62 millimeter Indian made is being used. This is 7.62 SLR. The length is about 44.85 inches. The effective range is about 600 meters. And the barrel length is 21 inches. And the weight, loader rifle weight is 5.5 kg, and without magazine, the weight of the gun is 4.396 kg, and the magazine capacity has 20 rounds firing. And the rate of firing is about 60 round per minute. And this is having a foresight, and which is a adjustable pole type foresight, and the system of operation is by release of gas. And this is having a box type magazine. Another one is AK-47, that is also a 7.62 millimeter lightweight Russian made. The term AK is derived from Andrei Kalashnikov, a Russian man who designed this rifle. And here the magazine is in front of the trigger. Another rifle that is being used is INSAS. INSAS means Indian made assault rifle, Indian small arms system. And this is the standard weapon of the enemy, that is INSAS 5.56 millimeter caliber. Another gun that is used is Ghatak 7.62 millimeter Indian made gun. And some short range weapons that are used for urban warfare by our state police is MP5. This is MP5, that is originally German made machine gun, that is 9 mm. Some pistols are there, and some light machine guns that are used for taking sniper shots, long range shots, are also there in the arms collection of the state police. And some 303 rifles that were used have all been almost phased out and are mostly used for ceremonial purpose and training in battalions only. So this is the weapons that are used by our Kerala state police. Another type of firearm is the paradox gun, and this is a ball and shot gun, and it is also known by the marketing name paradox gun, and it is a shotgun, and this is capable of firing both short and solid projectiles. And this paradox gun was first built by Holland and Holland, and the term paradox is a proprietary name applied to these type of guns by Holland and Holland. Another type of firearm weapon is gyrojet. So gyrojet is a family of unique firearms that are developed in the 1960s, and the gyrojet is named for the method of gyroscopically stabilizing its projectile. So the bullets that are fired from a gyroscope or a gyrojet is gyroscopically stabilized, and these guns, this type of guns, fire small rockets called microjets instead of bullets, and they have little recoil and does not require a heavy barrel or chamber to resist the presence of or the pressure of combustion gases. And velocity will be very low, and it can be increased to around 1250 feet, that is above the velocity of sound, and the result is a very light weight gun and also easily transportable weapon. This is gyro jet. Now we can compare different types of firearms. So in shotgun, the bore is about 4 to 12, sometimes can be 20, and the common bore is 12 gauge shotgun. And in case of muskets, the bore is about 0.410 inch. Air pistol or air gun 0.177, 0.22, 0.20, etc. Rifles can be having a very wide range of bores from 0.20 to 0.474 inches. So the muzzle velocity of shotgun is about 1000 to 1200 feet per second. Muskets muzzle velocity 1700 feet per second. Air gun or air pistol, the muzzle velocity is 200 to 400 feet per second. Rifle to 2500 to 3000 feet per second. Revolver 800 to 1000 feet per second. And in case of pistol, it is about 1000 to 2000 feet per second. So the most largest muzzle velocity is seen in bullets. Range of firing is 60 to 70 yards in case of shotgun. In case of muskets, it is about 150 yards. Air gun 20 to 30 yards. Rifle can be having a large or a long range of firing, that is about 1.6 kilometer, and accuracy of hit is mostly seen in 600 to 700 yards. After that, accuracy is reduced. So in revolver, the range of firing is about 80 to 100 yards, and in pistol, the range is about 100 to 120 yards. The projectile that is used in shotgun is multiple pellets or a slug can be used. In case of muskets, a single large pellet can be used. In case of air gun, lead slug is used. And in case of rifle, revolver, and pistol, bullets will be used. Now we have to learn about the cartridges that are being used in the firearms. So cartridge, or otherwise called as round, is the ammunition that is used in firearms. And cartridge can compose of two different parts. And this is a cartridge that is used in a rifle, and this is a cartridge that is used in a shotgun. So basically, four parts are there. There will be a cartridge case like this, or like this. The cartridge will be cased, and it contains a bullet or a pellet or slug. And the second component is gunpowder. The third component is the missile or the pellets, or sometimes slugs will be there. And in case of shotgun, and another important content is the wads, or the part that separates the gunpowder and the pellets. So in shotgun, the cartridge case is cylindrical, and usually the cartridge is having a length of 6 to 8 centimeter, and the base of the cartridge that is used in shotgun will be brass. You can see the base is actually brass, and the rest of the part can be cardboard or plastic. So the base will be brass, and the rest of the part will be cardboard or plastic. Usually the base will be having a rim. So the purpose of the rim is to fit the cartridge properly in the barrel, and the center of the uh, base has a percussion cap. This is the percussion cap. You can see a center of the base having percussion cap, and the component of a percussion cap is the primer. So, primer is actually a sensitive compound which contains potassium chlorate, antimony sulfide, mercury fulminate, barium nitrate, lead peroxide, or tetrazine. And the function of primer is that while the firing pin strikes the primer, this will be producing a spark, and the spark travel inside through the flash holes. There is a flash hole here, and it travels to the gunpowder, and this in turn burns the gunpowder. And this is how the cartridge works. So in case of a, non-rifled cartridge, you can see the base is composed of brass, and the base of the cartridge will be having a inscription like this. This is Winchester 12 gauge shotgun, and Remington 12 gauge. So this area, or the base of the cartridge, if we can collect, or we can uh, find out the base of the cartridge at the crime scene, this can give a clue to the type of weapon that has been used for the assault. And here is the primer, and here is the primer cap. You can see clearly at the base of the uh, cartridge there is a primer or a percussion cap, and this is the primer hole, and here is the gunpowder. Here is a wad column that separates the gunpowder and the pellets or the projectile. And this casing is made up of cardboard or plastic, PVC. And this is a wad column here, and this separates the gunpowder here and the projectile, or it is the slug. This is the composition of a cartridge, non-rifled cartridge. But in case of a rifled board weapon cartridge, or the cartridge that is used in a rifle, you can see the cartridge case that is tapering, and the whole of the cartridge may be based of brass or steel, and the size of the cartridge depends upon the weapon, whether it is a rifle, revolver, or pistol. Base will be rimmed. You can see the presence of a rim here. Then there will be a primer, and the primer contains the percussion cap, and there will be a flash hole from through which the ignition passes to the gunpowder. And in case of rifled weapons, after firing, the cartridge case remains in the barrel, and this has to be taken out manually, or in case if it is a automatic weapon, the cartridge case will be ejected out automatically. This is the cross section of a rifled cartridge. You can see the primer here, and the base of the cartridge. You can see the maker's mark, 0.243 cartridge, or a 0.223 cartridge. You can see the markings here. So if this cartridge case is found out from the scene of crime, it gives a clue about the type of gun that is being used. And after that, you can see the projectile and the gunpowder and the projectile here. It can be a naked bullet like this, or a jacketed bullet like this. The propellant that is being used in a cartridge is basically gunpowder, and the gunpowder can be of having the property like it can be a powder, can be particles, can be pellets, flakes, or hollow cylinders. And classical gunpowder is known as the black powder, and this composed of charcoal 15 percentage, sulfur 10 percentage, and potassium nitrate 75 percentage. So the potassium nitrate supplies the oxygen for it to burn, and depending upon the fineness of the gunpowder, it is designated as FG, FFG, FFFG, etc. And sometimes smokeless gunpowder is being used. So in addition to the black powder, it has a nitrocellulose single base, a mixture of nitrocellulose and nitroglycerin as double base, a mixture of nitrocellulose, nitroglycerin, and nitroguanidine as triple base. So nowadays, double based smokeless gunpowder is not used because of the very high temperature generated inside the chamber. And semi-smokeless gunpowder is also there, which has 60%, sorry, 80 percentage black powder as well as 20 percentage nitrocellulose. So what is happening inside the chamber? That is, if 1 gram of ordinary black powder is burned, it forms about 3000 to 4000 cc of gases, while 1 gram of nitrocellulose used about 3 times, that is 12,000 to 13,000 cubic capacity of gases. And usually the gases formed are carbon monoxide, carbon dioxide, hydrogen sulfide, and methane. Now about the projectile or the missiles that are being used in shotguns, it is called as pellets or shots. So the name shotgun is being derived. And in shotguns, the projectile are usually small, round lead pellets, and usually multiple in number. It can be ranging from about 1 to 2,600 per cartridge. Then the total weight of the projectile is about 1 to 1.5 ounce, and 1 ounce is equal to 28 grams. Sometimes the pellet can be soft or it can be hard. And if soft, it is made of lead, and if hard, also called as chilled shot, the lead is hardened with antimony. In shotguns, a rough idea about the number of pellets in a cartridge can be had from the marking on the top wad over the short wad, and the number of pellets in a cartridge may vary from 1 to few thousand, and accordingly they are classified as, if one pellet is being used, it is called a ball cartridge. Sometimes LG 6 pellets of the size 0.36 used, it is called large game. So game refers to the size of the animal, so it is used to kill a large animal. Sometimes it is marked as MG or medium game. Uh, Total number of pellets is 8. In case of SG or small game, the total number of pellets is 10, or it is having the size of 0.33 inch. Then 2 to 20 it is called buckshot, 200 to 400 is called bird shot, 2000 to 3000 is called dust shot. So in case of a rifled weapon, the projectile is usually a single one. It is also called as a bullet. And the anterior part of the bullet is outside the cartridge case. So this part will be outside the cartridge case, and the bullet is kept tied to the cartridge case by grooving called cannelure. This is the cannelure. And this cannelure keeps the bullet tight in the cartridge case. And usually the weight of the bullet ranges from 2 to 33 grams. And the part that extends from the cannelure to the tip of the bullet is called the nose. So from cannelure to the tip, it is called nose. And the nose can be of different type. It can be pointed, rounded, flat, or hollow. And sometimes the nose may be soft or hard, and if it is soft, it is by lead, and if it is hard, the lead will be hardened with antimony, as seen in our shotgun cartridge holes. The bullets may be naked or jacketed partly, fully, or double jacketed. And the jacket that covers the bullet, this is a jacketed bullet, and this can be made of copper or nickel, steel, or brass. You can see the different types of shotguns here. For reference, in the picture you can see a Duracell battery to assess the size of the shotgun cartridge. And here is the bullets that are used in rifles, the size of a .22 LR, then large bullet. And for reference, $1 is kept here to approximate the size of the uh, cartridge. This is the fully jacketed or the double jacketed bullet. Here you can see the primer, then the gunpowder, and the projectile here. This is a bullet that is a soft nose bullet, and it shows mushrooming. And there are different varieties of bullets. The commonly used, that is the incendiary bullet, because the tip of the bullet contains white phosphorus, so it catches fire on hitting the target. So the tip contains an incendiary mix, and the tip of the bullet contains white phosphorus. Another variety of bullet is explosive bullet, and the tip contains a detonator or a compound called lead azide, so that the bullet explodes on hitting the target. And nowadays, explosive bullets are not allowed for use. And Ronald Reagan has been shot by a explosive bullet. .22 bullet was taken from his lung by the surgeons. Dum dum bullet is a soft nose bullet. This is a soft nose bullet, and the nose will be cut, or there will be a cavity on the nose so that it explodes on hitting the target. But dum dum bullet is also not used now. And another type is tandem bullet or a piggy tail bullet. That is if during firing the bullet remains in the barrel, and this is the picture for tandem bullet. On firing, the bullet fails to exit the muzzle end, and on subsequent firing the second bullet eject carrying the first bullet, and on firing bullet fails to exit muzzle end. And if during firing the bullet remains in the barrel during subsequent firing, two bullets, one behind the other, are projected out, and they may hit the body through same or different wounds. Therefore the wound of entry may be single or double, but the wounds of exit are always two. Sometimes a cartridge will be having two bullets, which is called tandem bullet or duplex cartridge. You can see in this cartridge, two bullets are there. So in a single firing, two bullets will be exited. Another type of bullet is, or variety of bullet is a soft nose bullet, which mushrooms after hitting the target. And this will increase the surface area, and the damage will be more. Another type of bullet is the plastic or rubber bullet that are used by our police force to control riots, and these bullets are made up of PVC or rubber. Another variety is souvenir bullet, that is a bullet which has been lying in a body part since long, and it can be surrounded by fibrous tissue, and this is removed after a long time. And sometimes, very rarely, lead poisoning can also take place. Another variety of bullet is a tracer bullet. This is having ignition at the tip, called barium nitrate, magnesium, or strontium nitrate, and this will give a red flame while it passes through the atmosphere. And so this is named as tracer bullet, as it leaves a trace in the atmosphere. And the last part is wads, and these wads are present only in the cartridge of a shotgun, and wads can be made of paper, cardboard, hardboard, plastic, cork, or cloth. And the wads are used to separate the various compartments of the cartridge, like gunpowder compartment, the pellet, or the slug compartment. And the vads help in maintain the shape of the cartridge. So by maintaining the shape of the cartridge fits tightly in the barrel, and therefore gases do not leak. And so as a result, muzzle velocity will be more, and the range of firing will be more, and it also cleans the barrel. Now, coming to the end of this session, you can see the different types of uh, cartridges that are used in our guns. You can see in this picture a slug, a buckshot, a magnum number 4 shot, and the different sizes of cartridges used in different guns. You can see the picture, naked guns, naked cartridge, fully covered, uh, jacketed cartridge, etc. So we are coming to the end of the session, and in the next class you will be learning about the effects or the terminal ballistics, what is happening at the target. Thank you for listening.